episode of Corporate CPR, where we breathe life back into your organization, projects, and processes, giving you insights to recovery and avoiding corporate mortality events. Today, we'll be talking about why adopting AI is critical to the future of your company. And joining us to contribute to the conversation is Guillaume Herve. Welcome, Guillaume.
Nice to be here. Thank you.
Would you like to give our audience a little bit about your background?
Yeah, so Guillaume Herve, I'm the co-founder and CEO of Zetane Systems. We're an AI company based in Montreal, Canada, with an international client base, specifically in the medium to large companies. And what we do is we make the world of AI safer and more trustworthy by deploying software solutions that help people understand, explain, test, and validate what AI software or AI solutions will do prior to deploying them in the real world, our world.
So let's start a little bit with some basics, because when we hear the word AI, maybe we think about Will Smith and his movie or whatever, and it can be a little daunting, like, or some sort of, we think it might be a big elaborate type of solution, but are all AI solutions elaborate? Can you talk a little bit about what AI means?
Yeah, so, AI, artificial intelligence, is actually a very wide field that has been around for a relatively long time. And initial AI was basic, statistics and business intelligence, where people were predicting things out of data that you had gathered using relatively simple statistics or mathematics. And over the last 5 to 10 years, you've seen the world of AI evolve towards what we're not referring to machine learning or deep learning, very scary terms for the average person. And what machine learning and deep learning is really massive models that are ingesting large amounts of data to identify patterns and make predictions that humans would typically make, but maybe slower. And the idea being that you're providing an ability to a company or a human being to be faster, to be smarter, to be more accurate than the human can do by themselves. Now, one of the great examples that you just mentioned, iRobot, is a great example of what people think AI does, or maybe Terminator. There are a lot of movies out there that give you the sense that artificial intelligence is replicating all of a human being, and that's just not true. Artificial intelligence can only mimic or replicate a process or an activity that a human already does, but it has no judgment, it has no independent thought, it has no perception of its world. It only knows what you trained it to do, and it can only do that one thing. Now, complex models can do 2, 3, 4 things in parallel, but they're still only good at those things. They cannot extrapolate into something that they've never been trained to do. And I think that is the part that is scary or somewhat misunderstood in the general public, because we're thinking of AI as, independent robots that can take over what humans, typically think of themselves as human beings, and they're not. They're just robots that are trained to do something very, very well. And in fact, one of the big problems that we're seeing over the last few years is we've been very good at doing that, but because they're only trained to do things very, very well, they do a lot of things badly. They're just not meant to do. So if you don't test and understand what we call their performance envelope, their sandbox as to where they're going to be very good, then it can be dangerous, because you could send an autonomous vehicle out in the wild thinking that it'll be able to predict or react to every possible condition that you and I can react to as a driver. But the reality is that the algorithm behind the AI was only trained to do a certain few things well. And if you don't understand what they don't do well, then you won't know when to turn that off so that the human can take over. And that's really that delicate balance, when does the human, or human in the loop, as we like to call it, has to come in to override or augment what the artificial intelligence is recommending you to do.
Well, then, so you mentioned deep learning then, and talking about how the robots aren't going to learn what they aren't already trained to do. So how does that deep learning then? What does that mean?
Yeah. So deep learning is the most advanced level right now of artificial intelligence, where basically you're able to gather a set of data that you believe is representative of what it is that you're trying to replicate in the real world. So I'll give you an example. You are in deep learning, you're able to have models, and the models, an AI model is really just algorithms. They're just equations. You know, people think of AI like, what is that? Well, it's a bunch of equations. Mathematicians have come up with them in labs. And what happens is in the lab, everything is perfect. You know, when you see papers, and there are papers published every day of, oh, a new algorithm that can predict something based on a certain data set. Well, that's in a perfect lab where there's no snow, ice, sun glare, night, there's no dust, there's no broken camera, there's no vibration, you know, all the things that you find in the real world. And so what deep learning tries to do is it tries to say, if I give that algorithm enough of a varied data set that represents everything about the environment that I want that algorithm to work, then after days, and it can take days or even weeks of training, okay, like this is like the cloud is working and you're sending data up and down, and eventually the algorithm has an accuracy of how well it can predict something given all the data that you fed it. And deep learning really tries to do that using very complex algorithms, and sometimes several of them in parallel. And then once you've done that very well, then it goes into what we call an inference mode. So it's now a live AI, you know, a live set of algorithms that are out there. And in theory, if it sees anything that is representative of the data that you've initially trained it on, then it will identify it, then it will recognize it, then it will be able to make some sort of a conclusion about it. Now, the problem with deep learning is because the data set is so large, two things can happen. Either you can introduce bias because you've only used a part of data that only represents part of the real world. And a good example of that is actually in recruiting or parole. They've used AI to determine parolees are good to be paroled after so many years in jail. And in both cases, they've determined and they've demonstrated that if you've only used, I'll use an extreme example, but if you've only used a data set that replicates white European males' behavior, well, the algorithms will be very good at doing that. But if you have a white female or a non-white female or a non-whatever, you know, denomination that was not part of your data set, then the algorithm will be confused and it will typically be biased towards a negative outcome because of the way you've trained it. So that's bias. But the same thing can happen in a vehicle. You know, if I've trained my autonomous vehicle to drive in the summer, spring, and fall, and I've never trained it to actually work in winter, then if I start putting snow and different things in front of the camera, it just won't know what it is because I've never showed it. So that's bias. You've only given it information. It's no different than humans, because we learn, and if we only see so many things in our lives, we make conclusions, and all of a sudden we see something new and we're not sure how to interpret it. Kind of the same thing for the algorithm, except we have judgment. We have the concept of the environment. The algorithm does not. The AI does not. The second problem with data sets, when you're talking deep learning, which is massive data sets, is have you covered enough of the performance envelope, or the sandbox, as we like to call it, as to where you expect the AI to live in and to do well? And do you understand the conditions outside of that sandbox where the AI is not meant to work? And do you know what those conditions are? So bias and operational conditions are two elements that become very confusing in deep learning because it's hard to understand all of your data and how it impacted your algorithm or your AI models.
One of the things I've heard about is using AI in the customer service space, and no, I know there's some work going on where it's trying to interpret even the mood of the customer based off of words or tone in the email, and to me even that seems really difficult, because how do you determine sarcasm versus or being super cordial? So can you talk a little bit about that and whether or not that's really on the horizon?
Yeah, so the answer is yes and no. So it goes back to the previous question. So think about our experience determining mood and tone, whether speaking directly for somebody or reading an email. It's usually very culturally based. So the tone that you will use and I will use to debate a difficult situation with a customer will be very different than a Japanese to a Japanese, or an Indian to an Indian, or a Chinese to a Chinese, or a French or a German. And so it's very much culturally based. And so there's been good work done in trying to do customer service and mood detection, and being able to elevate a discussion as soon as you perceive, or the AI perceives, that there's something going on that is just out of the ordinary. But it's very contextual, based on the culture that you're trying to replicate. Even think of the U.S. I mean, I've traveled the U.S. quite a bit, east, west, north, south. I mean, the conversation goes very differently, and so you can't even just broaden it to just a country, right? There's sub areas that you've got to do that. And so again, an AI algorithm cannot learn those differences. You've got to train them. So you'd have to have very specific models that represent a large majority of a section of the group that you're trying to interface with the AI, because it will be biased to the cultural environment and the nature of that group that you're trying to represent, either orally or in written. It's called natural language processing. So there's a whole field of AI around understanding the spoken or the written word, and how to interpret it, in a way that really mimics that particular cultural representation. So we are there, but on a case-by-case basis, to answer your question. But broadly, there's not one that does them all.
Yeah. And it seems like it would be a hard challenge. I mean, even we talk about, just when you talk about communication between two humans, that the written word is only 7% of the communication. And so, even humans have a hard time. So how are you going to teach out of it? Yeah.
And remember, it goes back to the original, an AI, an artificial intelligent algorithm, is only trained to replicate what a human already does.
Right.
We haven't defined AI to do something that nobody's ever done in their life. So it's exactly what you just said. We're trying to replicate humans, and we're having a hard time. So, given all the context and the body cues and the smiles and the eyes and so on, the AI doesn't have that. So very limited in scope still.
Absolutely. Well, so let's bring it down a level and talk about more of our everyday companies, our non-tech companies. How do they approach using AI to be more competitive?
Yeah. So what we're seeing, certainly in the projects that we've done, and a lot of the research, we're constantly looking at this stuff. I think the last few years have taught us a few things in terms of how to look at AI in industry, and how to start, deploying it and making use of it. So I think, for people that are listening, I think the number one takeaway that has come out of a lot of the projects that we've done is you've got to have a clear use case, a clear situation that you're trying to solve, because AI is not the right tool for every job. And so often, we're trying to force fit AI when another solution would have done just fine. So what is the use case? Is it a supply chain environment where you're trying to optimize a supply chain? Is it a cost, efficiency optimization? Is it speed? Is it trying to get, to more customers? Is it trying to bring, to use some example in customer support, new experiences with new tools? And so defining a clear use case, where then you're able to ask the question, is artificial intelligence the right tool for this, or are there other solutions for that? And so a clear use case is number one. People used to go into AI like, oh, we've read a paper, we saw one of the consulting companies pull out an article about using AI for gas emission detection, or voice recognition, or tracking cats and dogs in the backyard. So okay, let's do that, right? And the reality is it's not that straightforward. So what's the problem? Number two, one of the big mistakes that was made with AI in the early days is because it's all about big data, people thought, well, I have a lot of data, I'll come up with a big project. And what we've seen over the last few years is actually scaling back and starting with what people are referring to as proof of concepts. So if once you've defined your use case and you've confirmed in your mind that AI would be the right tool, what's a small size project with a small set of data that you can see if in fact AI will give you the outcomes you're looking for? And we're talking about the big buzzword around AI these days is data-centric AI, which means make sure you have a quality set of data. Quality trumps quantity, especially in a proof of concept, so that you're able to say, okay, my data set is representative enough I understand my biases, I understand my operational context, and I'm going to now feed it into these algorithms and make sure that they actually work in the real world at a small level, a small scope proof of concept level. And once that's done, then you can move to medium size and a large scale project. The third thing I would say, which has been maybe the number one reason AI hasn't had as much adoption in companies, is AI was often worked on by the geeks in the basement or in the lab. And they'll work on a project for months, and then they'll show up to management and they'll say, guess what? We've come up with an algorithm that can do this and that. But management lives in the real world. Management knows that if they leave, if they let one of these algorithms in the wild, as we like to say, well, there are real consequences if it doesn't work properly. Client satisfaction, all the way down to accidents if you're using something in autonomous vehicles, for example, or bias in human resource decisions or banking loans. There's a lot of harsh consequence to the algorithms not working properly. And so what we're seeing now is actually a lot more involvement from operational people right in the use case, right in the proof of concept, and every step along the way. So they get to buy into what the data scientists and the machine learning engineers are developing, so that by the time the end solution is being demonstrated, the group already understands, how the algorithm decides and what data it's using and what are the operational conditions under which it won't work. So that you can, as the business leader yourself, you're able to say, okay, now I feel secure enough that I can approve that this gets deployed in the real world.
So are there frameworks or, best practices or something to use to evaluate those use cases? How does, like you said, there's some companies who are just like, love the latest trend and they jump on it and it doesn't fit. Or sometimes companies avoid the latest trend and probably don't use it when it is appropriate. So how does that evaluation work?
Yeah, so I've seen I've seen probably 3 different company models in terms of how companies go about this. So you've got the companies that have decided to build their own AI teams internally, so they'll hire data scientists and machine learning, deep learning people, and bit by bit they'll try to create that capacity internally. I've seen the other extreme where they figured, okay, let's just outsource all this. Let's be really good at understanding our use case and understanding where AI can and cannot help, but let somebody else build the AI because we don't need to build it if we really are confident about our use case. And then I've seen it, in between, small little AI teams, and then they'll work with external groups to scale a solution. And so when you look at the environment of AI, and for people that are listening that are used to the software world, the software world was often a very closed world. You had to buy software, you had to hire people to understand how to develop their models. The AI space is actually pretty cool for that. So there's a lot of open source material available where you can get pretty far using open source models, open source data sets, and open source development environment and libraries. And so that gives most companies, quite a bit of access and quite a bit of speed if they want to get up and started with AI. The problem is, if you're not an AI person, you won't know how to use these environments. So you certainly need either data scientists or people like that understand where to find these open source tools and data sets and environments. But they're available. You don't have to invest a lot from a tool perspective to get very far. The second thing is researchers are publishing models at an incredible rate, as I mentioned earlier. And these models are available for free, meaning that you can replicate the model. And a model can be, how do you recognize a voice, or how do you read a text, or how do you identify a certain type of object in a certain background, or how do you coordinate massive data as to make a client decision. So those are models that have been developed in labs, though. Always remember, it's always in the lab. And so you can use these lab models as a starting point. The tricky part is, how do you then, train that lab model in a real world with massive new data that it's never seen before to make sure that it's going to work. But the environments are available. You've got a pretty large open source. You've got a pretty large free model sort of environment that are coming out. So from that perspective, not scary, very, very accessible. But you've got to know, if you want to develop your capabilities internally, or like I said earlier, do you want to develop the know-how of AI, but let somebody else develop it for you? And there are plus and minuses to these approaches, of course.
And then I guess, what are some of the other key failure points in these type of projects? Obviously, if you aren't starting with a strong business case, that can end up in failure. You mentioned data, using proof of concept as a best practice, but what are some other failure points for people who take these?
So one of the main failure points that has become sort of the focus of a lot of companies and companies either that are developing AI or tools like ourselves for the AI community is what they call explainable AI or explainability. And this goes around this concept in AI that has been well documented, which is called the AI black box. So AI is not like software development. So when people do software coding back in the day and today in C or C++, whatever language people use, you can create your software code and you know exactly what each line of code does. And you're able to, pinpoint if somebody asks you, well, why does it do that? Well, because over here in my code, it says to go left instead of go right. Okay, get it. I buy into that, approved, and let's deploy it. AI doesn't work that way. You're training a model with data and you don't really cut code. You don't write code. It's libraries that are learning from data that's coming through. And so to understand and explain what's going on takes a whole different turn. And for too many years, what was happening is the AI teams in industry and research academics and research centers around the world were just saying, trust me, it works. It's a black box. Can't really explain why it works, but it works because look, here's my results. Here are the results. And that was fine when people were doing, funny apps that you can download to play with. And if it doesn't really work well, who cares? Right? You don't have to explain why the cat's a cat, what's a dog's a dog, or why I can spot a butterfly and why I can spot a bird, But if you're going to be able to convince people that I can deploy it in my car for autonomous driving, or I can deploy it, in an energy grid to determine whether you're going to get electricity or not tonight, or if I'm going to deploy it in a medical device that's going to, recommend whether somebody has cancer or there's a suspicious growth in a part of an MRI or an X-ray. You want to know that it's actually working the way it should be working, because you're making pretty risky decisions, and the impact of failure, the consequence of failure, is very high. And so explainability has become a big issue, because the more AI has moved into industry, the more decision makers live in the real world, and seeing is believing, and a black box just doesn't cut it. So at Zetane, for example, we've developed a set of tools that allow you to replicate an AI algorithm in what we call a human understandable model, that you and I, even you being a non-AI person, I could walk you through that model and you would say, okay, I get what each part of that model does. And more importantly, I understand how the data you used influence that model to make a decision. And as a person that doesn't know AI, but as a person that knows your business, you're able to say, that makes sense or that doesn't make sense. And that's what people want to see now. They're saying it's because of this deep learning, these very complex AI architectures, it's too complicated to just trust. And so explainable AI and trust AI is the other term that you'll hear. Becomes very important in industry. Most decision makers won't just say, oh yeah, I'll take your black box. I don't know what's going on inside, but if you tell me it works, I guess I'll trust you that it works. Doesn't work that way. Yeah. And so that's the big tendency right now: trustability, accountability, explainability. And the other term that you hear that your audience might hear about is what they call robustness, which is when will the model work and when will the model fail? Because every model will fail, because they're not human beings, and frankly, we all failed as well, but we're able to contextualize our failures. And so being able to understand when your model will fail and when it won't be robust anymore becomes a critical aspect. And then the one thing that I would also share with your audience, I think, is that we tend to think of AI as it has to be 100% accurate. And that's just not realistic, because we're not 100% accurate. But there's a mindset out there that if I'm going to use AI, it's going to have to be 100%. Okay, but the human at that particular task might only be 72% accurate. So if I can give you an AI that works faster and gives you 84%, well, that's really good, as long as you know the 16% when it's not going to work, right? Because that you need to understand. But I think companies have to get away from this idea that it has to be 100% to be deployable. It's a misnomer out there. AI is not perfect, and it's got to be as good or better than the human and faster and cheaper, then it's worth considering.
Do you think that's because we expect software to be 100%, and so therefore we expect AI?
Yeah, it's exactly that. Over the years, remember back in the day, I mean, when you get the blue screen on your computer because everything would fail, it was panic. We don't get that anymore. And so, I think there's a perception that, in the last few years that software is perfect. So AI must be software, so it must be perfect. But even software is only as good as what it is you've developed it to do. And if you want to break software, as the old software coders will say, they can always find a way to break it. And so I think you're right. And I think movies, you've never seen, Iron Man. You've never seen the AI that's, always talking to Iron Man fail. You've never seen iRobot fail. You've never seen Terminator fail until the very end. So there's a sense that I guess it's never fails because it always seems to react properly, but it does fail. And you can't expect 100%. You can only expect it to be, like I said, better, faster, and more accurate, but not perfect.
You mentioned talking about like the risk in, I guess, deploying it, as in, was it created in a vacuum or was the real world applied? So can you talk about some of those risks and what strategies executives use to mitigate those?
Yeah, so what we're seeing a lot more now are specific governance by executives around how AI needs to be validated, tested, evaluated, and verified before it gets deployed. And that is very much being inspired from the software world. In the early days of software, it was a bit of a free-for-all, and then people started developing testing protocols and testing software and testing matrix. And then you had to have different levels of approval, and you had to go through testing protocol. And at some point, either a separate QA group or a separate test and evaluation group would say, I've taken Guillaume software, I give it to an independent person, they tested it, all good as per the specification. So yeah, we can let it go. That is not, believe it or not, that is not instituted yet in most companies that are doing AI. So this, and because it's not software code, it's hard to test, right? You can't test the modules of software and sub modules the way you do software, pardon me, in the AI world. So you need a different set of testing methods and tools to be able to test AI. And people are starting to realize that if you're going to do little projects in your lab, don't need much testing. But if you're going to do what we call large-scale deployment of AI in a business environment, then you need a governance and you need a test and validation verification protocol like you would releasing software. It just needs to be a different approach, but it's the same outcome. Independent people testing what the engineers and the developers have developed to make sure that independently it still does what it's supposed to do.
That's great. Well, this has been a really interesting conversation, Guillaume. Do you want to talk about maybe what are your top 3 things you want to leave with the audience today?
Yeah, top 3. When I'm often in front of C-suites and decision makers. The one thing I say is I think people need to move quickly on AI. Meaning you got to get informed. And you've got to understand what it can and cannot do as a business leader. That doesn't mean that you're developing algorithms. But I think I'm pretty convinced from what I've seen that AI is coming quickly. So that's number 1. Number 2, I would also move quickly, but be cautious on how I introduce it in the company. Because don't believe in all the publications where you read or you see a YouTube video of an AI doing something pretty cool. Typically, it's in very controlled environments, like I said earlier, lab conditions, so everything looks perfect. And the error that I've seen a lot of executives do in business is to think, okay, let's take that, and in 3 months, let's deploy it. It doesn't work that way. It really doesn't work that way, because all that you've seen on YouTube is that the concept works. Now you've got to take your own data, make sure that it's not biased, make sure that it's representative, and you got to put it through the model, and then make sure that it actually works in your real world environment, which, by the way, it's not necessarily the same real world as a similar company halfway around the world, because the way they're deploying it might be different. So that would be number 2. And then the third thing I would say is in my top 3, don't make the mistake of letting your AI teams or consultants, if that's what you're using, develop things in vacuum. involve the operational people, the people that will have to buy into the end solution as early as possible. What I mean by that is let them understand not what AI is, but what AI is going to do for them. Make sure that they buy into the data that you think is going to be representative. Make sure that they understand how the algorithm is influenced by that data to make that final recommendation, and let them tell you what makes sense and doesn't make sense. Because again, the model is only as good as the way you've trained it. And so involving operational people early will ensure one thing, and I'll leave you with that the latest studies on AI in industry has identified that about 80 to 85% of AI projects in industries do not make it into deployment, do not make the light of day. That's a big investment, right? 80 to 85% that is not getting deployed. And it's one of the top 3 reasons is lack of business or operational buy-in through the AI development process. So that's why I'm leaving the audience with that particular piece of information.
Yeah, that's pretty indicative, though. I think across technology projects is nobody gives change management a thought until the end, and then you have an adoption problem.
It's exactly it. It's a great way to conclude. It's all about change management, and AI is a new technology, just like other technologies were. Virtual reality before when it first came out, people were freaked out. And then now people don't think to be too scared. I always use the example of you and I now don't even question depositing a check by taking a picture through our phone and depositing it in our bank account. Well, that's massive AI, because first of all, the camera has to recognize that it's a check. And then the AI has also to recognize the numbers and the letters that you've written to make sure that it's a proper check and that it's the right, and it can't make a mistake. If you said 811, it's not supposed to deposit 877, and if you did, 733, well, you don't want the AI to think the 7 is a 1, the 3 is an 8, and the other 3 is a 3. So all that is AI in the real world. But it took years and years from taking stuff into the lab and then making it applicable to your phone, which is different than my phone, which may be different than the other phone, with all kinds of problems in taking the photo. And so now, though, we take it for granted. I take that picture, my check's deposited, and I'm all happy. But the first time it came out, I wasn't too sure that I was happy with the idea, right?
Oh, I was an early adopter. Like for some reason, USAA seemed to be one of the first banks in the US to develop it, and they were using scanners even. So even before you could do it on your phone, you could scan it. And I was doing that, but I thought it was really funny. I ran into a friend who it took COVID before her husband would adopt it. So even up to 2 years ago, he was still making her drive to the bank to deposit checks because he didn't trust it.
You didn't trust it, right? And that's pure change management around technology. It really is. But that check being deposited to your bank account accurately without an error is a lot of AI behind it. Computer vision, i.e. recognizing a photo, and then natural language processing, understanding the written word, and making sure that words or numbers are accurate when they're interpreted by the AI.
Yeah. Well, Guillaume, how do folks get in contact with you or learn more about what your company does?
Yeah, so absolutely. First place to go is Zetane.com, Zetane.com. You can find out everything about us. Our software is available right now. People can use it, and we have services to help companies as well. You can get a hold of me directly at Guillaume@Zetane.com. So GUILLAUME @Zetane.com, and you direct email to me, and I'd love to get some feedback.
That sounds great. Well, thank you so much for your time today.
It's been a pleasure. Thanks for having me.
And to our audience, until next time, keep your organization.